Good morning, students. As we are discussing geometry and we have completed all the pairs of angles, independent of transversal we have completed and dependent of transversal we discussed in last class. Corresponding alternate interior, alternate exterior, co-interior and co-exterior, and along with their properties also. So today let's take a look at polygons. So what is polygon? So before learning what is polygon, you should understand two terms. What is simple figure and what is closed figure. So what is simple figure? A figure which does not cross over itself. A figure which does not cross over itself is called simple figure. For example, if I draw a circle, is it crossing over itself? No. But if I try to write number 8, so this is also a figure, it is a curve, but it is crossing over itself at this point. So this is not a simple figure. So you can say this is a simple figure. I'll use tick mark, and this is not a simple figure. I'm just writing cross. So it is not a simple figure. The figure which is not simple, we call it complex figure. So this is an example for simple figure, and this is an example for complex figure. And the number of times it is crossing over itself is called its degree of complexity. So for this figure, the degree of complexity is 1. The degree of complexity is 1. Suppose if I have a figure like this, so this is not a simple figure because it is crossing over itself twice, 2 times. Okay. So what is the degree of complexity for this? It is 2. And it is not a simple figure. It is a complex figure. Suppose if I draw a triangle, yes, it is a simple figure because it is not crossing over itself. Now, let's discuss what is closed figure. Closed figures, a figure, when you start to draw, you have to start at one point and you have to end at one point. That means for a curve, if the starting point, coincides the end point, then we say that it is closed figure. For example, if I take a circle already we took in the examples of simple figure and now closed figure. Suppose you start at this point and you go around and you come at the same point. That means starting point and ending point are same. So it is a closed figure. Yes, this is a closed figure. If I try to write number 8, where I start and I have to end there. Okay. So it is also a closed figure. Starting point and ending point are same. So 8 is an example of closed figure, but not a simple figure. Okay. For example, I try to write the curve representing number 6. 6, we start here, and we end here. Okay. So the starting point and ending point are not coinciding. So this is not a closed figure. Okay. And we can take any polygon like triangle, quadrilateral, etc. Suppose if I take a quadrilateral, you can start at one point and you go around it and come back to the same point. That means starting point and ending point are same. So this quadrilateral is an example of closed figure. So any doubts in simple figure and closed figure, you can raise a hand. I'll be clarifying. Any doubts? Student, you have any doubts on these two concepts? Simple figure and closed figure, you can raise a hand. Saharsha, what's your doubt? Saharsha, speak loudly.
Sir, I not understood simple figure.
Simple figure means it should not cross over itself. See here, let's take a circle. Is it crossing over itself anytime?
Yes, sir.
No, it's not crossing. Crossing over means suppose if I write number 8, the crossover is happening here, right?
Yes.
So the circle is not crossing over itself. Suppose if you try to write number 4, is it crossing over itself here?
No, sir.
Yes, it is crossing over. On the same curve, it is crossing on itself only. Yes or no?
Yes, sir.
So it is a simple figure or a complex figure? It's not a simple figure, complex figure. If it is not crossing over itself, it is simple figure. If it is crossing over itself, it is complex figure. Okay.
Okay, sir.
Ashwardhan,
Sir,
what's your doubt?
sir, why you said what is sir? I not degree of complexity.
Degree of complexity means the number of times crossover is happening. That is called degree of complexity.
Sir, why?
See, it is a definition. The number of times it is crossing over. This number 8 is there. How many times it is crossing over itself?
Sir, one time.
That's why degree of complexity is 1. And you take this complex figure. How many times it is crossing over itself?
Sir, two times.
2 times. The degree
Sir,
of
why?
complexity is 2. Suppose, let's take this figure. Okay. Can you see this figure?
Yes, sir. Star.
Okay. How many times it is crossing over itself?
4. Sir, 5 times.
5 times. So the degree of complexity is 5. You understand?
Sir, why we are calling that the degree of
That is a
complexity?
definition. The number of times a figure crosses over itself is called its degree of complexity. So we can write a note point about it. That is degree of complexity. Let me write the short form. Degree of complexity of any simple figure.
Sir, simple figure may have degree of complexity.
What is the degree of complexity of simple figure?
Sir, 0.
Yes, because it is not crossing over itself. So the degree of complexity of any simple figure becomes 0. Rishika, what's your doubt?
Sir,
Yes, Rishika.
sir, I didn't understand closed figure.
Closed figure means whenever you draw a curve, you have to start at one point and end at one point, right?
Yes, sir.
The starting point and the end point are coinciding with each other. They are nothing but the same point. Then it is called closed figure. See, on the right side, I started to draw a circle. Okay. I will start at this point and I'll end at the same point. Yes or no?
Yes, sir.
That's why it is closed figure. But if I try to write the curve representing number 6, I start here and I end here. That means the starting point and the end point are same.
No, sir.
That's why it is a not a closed figure and we call it open figure. Such type of figures are called open figures. Okay.
Okay, sir.
Arush, what's your doubt? Arush?
Sir,
Yes, Arush.
sir, I didn't understand closed figure, sir.
Closed figure, just now I told you now again. If the starting point and end
Yes.
points are coinciding, then it is closed figure. They are different points, then it is open figure. That's it.
Sir, what is mean by DCOD2?
Come again.
D DOC2, what is
DOC
mean
is
by that?
degree of complexity. I wrote in short. Degree of complexity means the number of times a figure crosses over itself is called its degree of complexity. See, this figure is crossing over itself here and as well as here. So at 2 points it is crossing over itself. So the degree of complexity is 2. Is it clear?
Okay, sir.
So moving ahead, so we understood what is simple figure and closed figure. Now we can define what is polygon. Okay. So in the polygon definition, we are going to use these two terms. That's why I explained. Now let us discuss what is polygon. Okay, polygon. A simple closed figure. A simple closed figure bounded by line segments only. Line segments only. So it's called a polygon. So I'll take several examples to make you understand. Let's take a triangle first, and let's take a quadrilateral. Let's take a semicircle. Let's take a five-pointed star, and let's take a circle. And let's take a sector of a circle, like pizza piece, and let's take something like mm, number 8 curve. Okay, let us check these. How many of these figures or curves are treated as polygons in geometry? Okay, so the conditions are very clear to call any figure as polygon. The first condition, it should be simple. Second condition, it should be closed. And third condition, it should be bounded by only line segments. We need to check these three conditions. Okay, so I'll be explaining first figure and remaining all I'm expecting from students only. So the first figure, triangle. So I want to check whether it is simple or not. Yes, it is simple. Why? Because this is not crossing over itself anywhere. So it is a simple figure. And is it closed? Yes. Suppose if I start drawing the triangle from here, I go around the triangle and reach the same point. So it is closed. And is it formed by only line segments? Yes, it is formed by only line segments. Straight, straight, straight. So only line segments are formed. So it is a polygon. Yes, this is a polygon. I'll use a tick mark. Then I expect all the students one by one. Okay. So next there is a quadrilateral. So I want anybody to explain about it. Quadrilateral is a polygon or not? Okay. Yes, Abhiday, can you explain quadrilateral is a polygon or not?
Sir, yes, sir.
Okay, is it a simple figure?
Yes, sir.
Why is it a simple figure?
Sir, it is not intersecting itself.
Okay, and why it is closed figure?
Sir,
Why is it closed figure?
sir, where it is that there only it ended, sir.
Okay, and what is the third condition? Is it formed by only line segments?
Sir,
So all the conditions are true. Can I say it is a polygon?
yes, sir.
Yes, very good. And the next we have a semicircle. Sriyansh, can you say semicircle is a polygon or not?
Sir, no, sir.
Why?
Sir, because it does not made by bounded by line segments, sir.
Okay, first two conditions are true for this.
Yes, sir.
Simple figure.
Sir?
Is it
Yes,
simple
sir.
and is it closed figure?
Yes, sir.
So it is simple and closed, but the third condition failed. It is not bounded by line segment because of this curve. So semicircle is formed by this curve. That's why it is not a polygon. No, cross. Very good. And
Sorry, sir, not.
Jayvant, can you say the next one? Jayvant? Jayvant, are you there?
Yes, sir.
Okay, this is a 5-pointed star. Do you think this is a polygon or not?
Yes, sir.
Okay, is it a simple figure?
Yes, sir.
What is simple figure, Jayvant?
Sir,
What is simple figure?
sir, you are not hearing, sir.
Jayvant, you leave the class and join again. Harini, can you say what is simple figure? Harini?
Sir?
Harini, what is simple figure?
Sir, simple figure means the figure which is not
Where is
intersect.
Harini? Where is Harini?
Sir,
Harini?
her throat is not good, sir.
Okay, okay. So this 5-pointed star, is it a polygon or not?
No, sir.
It's not. Why? Is it a simple figure first?
No, sir.
Why?
It is intersected by line segments.
No, no, no. Simple figure means what, first of all?
It is a closed figure which not intersecting.
It is not crossing over itself. Okay. But is the figure crossing over itself?
Yes, sir.
Yeah, that means it is not a simple figure. And is it closed figure?
Yes, sir.
Okay. If closed figure means? Closed figure means?
Sir, which starts from one point and ends from another same point.
Ends at the same point. Yes. Is it a closed figure then?
Yes, sir.
And is it bounded by only line segments?
Yes, sir.
But because of first condition failed, can we say it is a polygon?
Yes. No, sir.
No, this is not a polygon. Next, Bhuvana, can you say circle is a polygon or not? Bhuvana?
Sir?
Yes, Bhuvana. First condition, is it simple figure?
Yes, sir.
Is it closed figure?
Yes, sir.
And is it bounded by line segments only?
No, sir.
That's why it is a polygon or not a polygon?
Sir, not a polygon.
Very good, Bhuvana. You can mute now. Nishil, can you say the next figure that is a sector of a circle? Is this a polygon or not? Nishil? Vishnu, can you say this next figure is a polygon or not?
Sir, no, sir.
Why?
Sir, because it is not. Sir, it is not completely bounded by line segments.
But what about the first two conditions?
Sir, yes, sir, it does.
Yeah, but the first two conditions are satisfied, but not the third one. So it is not a polygon. Very good, Vishnu. And Daksh, can you answer this figure? The curve representing number 8, is this a polygon or not?
Sir?
Is it a polygon or not?
Sir, no, sir.
Is it a simple figure?
Sir, no, sir.
No. Is it a closed figure?
Yes, sir.
Yes. It is bounded by only line segments.
Sir, no, sir.
Only one condition satisfied, but the two are not satisfied. Will you say this is a polygon or not a polygon?
So not a polygon.
Not a polygon. So I hope everybody understood how to decide whether a given figure is polygon or not. Simple. So three conditions. What are they? It should be simple, it should be closed, and it should be bounded by only line segments. Now we are going to discuss about all the properties of a polygon. Okay. So discussing about the properties of a polygon. Okay. The first property is the number of vertices, the number of sides, and the number of angles are always equal in any polygon. Let's take a triangle. Triangle is the polygon having least number of sides. So the least number of sides required to create a polygon is 3, because with the 2 line segments we cannot create a polygon. Okay. So for this, let us identify the number of vertices. 3. 1, 2, 3. Now let's identify the number of sides. 1, 2, 3. So number of sides also 3. And let's identify the number of angles. 1, 2, 3. That means for any polygon, you can see number of vertices, number of sides, and number of angles are always equal. Let's take a quadrilateral. So vertices 4, sides 4, and angles also 4. So this is the first property they satisfied. So if you know number of vertices, we can say number of sides and number of angles are equal. And the next one is number of diagonals. But before discussing number of diagonals, we need to understand the concept of diagonal first. Okay. First, let us differentiate the side and the diagonal. Okay. So what do you mean by side? Side means it is a line segment. It is a line segment joining. It is a line segment joining adjacent vertices. Adjacent vertices. And then diagonal. How it is different from the side? Diagonal is defined as it is a line segment. It is a line segment joining non-adjacent vertices. Non-adjacent vertices. Okay. Now let's take an example of a figure and then discuss this. Okay. Let's take a pentagon. Okay. Pentagon is having 5 sides. 1, 2, 3, 4, 5. So if it's having 5 sides, number of vertices also 5. So let's take the same structure here. 1, 2, 3, 4, 5. Okay. Now let's name them A, B, C, D, E. And let us name this A, B, C, D, E. Okay. Now this A and B are called adjacent vertices because they are side by side and there is no vertex in between them. And AC non-adjacent because between them B is there. And AD non-adjacent because between them E is there. AE, yes, they are adjacent. So like this, so many pairs are possible. You can identify which are adjacent and which are non-adjacent. For example, CD adjacent, CE non-adjacent, AD non-adjacent, EB non-adjacent, DE adjacent. So you can clearly see adjacent and non-adjacent. So you take any two adjacent vertices and join with a line segment. The line segment is called side of the polygon. See, A and B are adjacent. So if I join A and B, I get a side or I get a diagonal. I get a side. And B and C also adjacent. If I join them, I get a side because I joined adjacent vertices. CD adjacent. If you join them, you get side, side, side. That means, what do you mean by side of a polygon? It is a line segment joining adjacent vertices. Now coming to the diagonal. You should not join adjacent vertices to get diagonal. You should join non-adjacent vertices. Okay. So I know A and C are non-adjacent. By joining them, I get a diagonal of this polygon, and I know CE non-adjacent diagonal. This is a diagonal of the polygon. EB diagonal of the polygon, because E and B are non-adjacent. BD also non-adjacent, so BD is a diagonal, and DA is also a diagonal. So you can see a 5-pointed star. But if you want to show the sides also here, yes, you can show. So AB is a side, BC is a side, CD is a side, DE is a side, and EA is a side. So for pentagon, so we took the example of pentagon here. For pentagon, we can say number of sides is denoted by S. Okay, number of sides is 5, number of diagonals also 5. Okay, so I think everybody understood what is the difference between a side and diagonal. If the line segment is joining adjacent vertices, it is a side. Non-adjacent vertices, it is a diagonal. Now, the question may be asked on finding number of diagonals. Okay, for pentagon, we understood there are 5 diagonals. Okay, first let us manually find. Suppose we take a triangle. Okay, so I took a triangle. So number of sides is 3. Number of diagonals is not possible, because you take any two vertices of a triangle, they're always adjacent. So we cannot get a diagonal. So the number of diagonals of a triangle is 0. Next, let us take a quadrilateral. We know number of sides is 4, but how many diagonals are possible? I want this answer from students. So who will answer number of diagonals of a quadrilateral? How many are possible? Raise your hands if you want to answer. Harshvardhan, can you answer number of diagonals of a quadrilateral?
Yes, sir.
How many?
Sir, name the points, sir.
Come again?
Sir, name the vertices. A, B, C,
Okay,
and
okay. A, B, C, D. So tell me.
sir, now A and C are what? They
Okay,
are
let me show diagonals with a different color. So AC I'm joining with yellow color. That is one diagonal. Where is another diagonal?
B and
B and D. So other than these two, any other diagonals possible?
sir,
No. So the number of diagonals, how many we got?
sir, 2.
So we got the number of diagonals is equal to 2. Very good.
Sir, we can
So
find the hexagonal diagonals.
yeah, everything we can find. We are going one by one. Next, we'll take a pentagon. Okay, pentagon we have already completed. Let me write it here for continuing this pattern. So there is a pentagon here. Pentagon is having 5 sides, and let me draw the diagonals: 1, 2, 3, 4, and 5. So we can write the number of sides is 5 and number of diagonals is also 5. Now let's take a hexagon. Hexagon is having 6 sides. Okay, 6 sides. Let me name the vertices also: A, B, C, D, E, F. So there are 6 vertices and 6 sides, so it is called a hexagon. I want to find the number of diagonals. So who will answer this question? Number of diagonals of a hexagon. Yes, Rishika, can you say the first diagonal what you can identify?
Sir, A and C.
Okay, AC is a diagonal. Okay, keep
Sir,
counting. Keep counting. It is 1. Okay.
Sir,
Okay.
B and A.
B and D. 2.
Sir, F and I. No.
It's E. A B C D
F
E
and D.
F. F and D.
Yes, sir.
3.
3. E and B.
4.
E and A.
5. That's it. Rishika, can you identify any more non-adjacent vertices? F and B, adjacent or non-adjacent? F and B. Rishika, are you there? Shanai, can you complete this? Rishika said names of 5 diagonals.
Sir,
Yes. Can you
sir,
continue?
A and C.
A and C
Sir?
over already. A and C over already. 5 diagonals are over.
Sir, wait, sir, 1 minute.
Is the figure visible to you or not?
Sir, you can scroll.
Is this figure visible to you or not?
Sir, no.
Is this visible now?
Yes, sir.
Okay, now you tell me. 5 diagonals
Sir,
are
A.
over.
Sir?
5 diagonals are over. Next diagonals you have to find.
Okay, sir.
Can I make it fast?
I am doing.
Come again?
Sir, I am doing.
Yes, Rishikesh, can you complete the diagonals?
Sir?
Yes, Rishikesh.
Sir, F and B.
F and B. 6 over.
Sir,
Next.
F and C.
Very good. 7.
Sir, D and A.
8.
Sir, E and C.
Yes. 9. Any other diagonals possible?
No, sir.
Very good, Rishikesh. You got the correct answer. So the number of diagonals we got for hexagon is 9. Okay. So let me put it here. So the number of diagonals we got is 9. So let's write here. The number of sides of a hexagon is 6 and the number of diagonals is 9. But if they ask you to find the number of diagonals of a polygon having 20 sides, we cannot draw all the 20 sides and start counting the number of diagonals. Then, so without proof, you can just remember one formula, that is number of diagonals is equal to n into n minus 3 divided by 2. Here n means the number of sides. You can use S or n, anything you want. So the number of diagonals is n into n minus 3 by 2. Proof also you can understand, but it takes time. Let's understand without the proof, that is n into n minus 3 by 2. So let's check this formula is working or not. Okay. So first of all, I want to find the triangle. Okay. In place of n, I'm going to use the number of sides, that is 3. So just substitute 3 here. So 3 into 3 minus 3 divided by 2. 3 minus 3 we know 0. 0 into any number is 0 and 0 by 2 also 0. So we got the answer 0. Yes. So this is matching. And let us check now for the quadrilateral. Is it matching or not? Substitute 4 here. That is 4 into 4 minus 3 divided by 2. We know 4 minus 3 is 1. 2 2s are 4 and 2 1s are 2. So we got the answer 2. Correct answer. And let's check for 5. For 5-sided polygon, how many diagonals we got? We already got it by counting 5. Let's substitute in the formula. 5 into 5 minus 3 divided by 2. We know 5 minus 3 is 2. 2 to cancel and the answer is 5. Yes, it is matching. And let's find for hexagon. Let's verify for hexagon. For hexagon, how many diagonals we got? It is 9. So 6 into 6 minus 3 divided by 2. 2 3s are 6. We know 6 minus 3 is 3. 3 3s are 9. So again, we got the correct answer. So using this formula, this is a relationship between number of diagonals and number of sides. If diagonals are given, we can find sides, and sides are given, we can find diagonals. And so this is the second property about diagonals, and then we are going to discuss about the third property, that is sum of exterior angles. Sum of exterior angles in any polygon. In any polygon is 360 degrees. Let's take a triangle first. Okay, this is a polygon. Now, what is exterior angle? Exterior angle is nothing but you have to produce one side or extend one side. So extended side and the regular side, the angle between them is called an exterior angle. And similarly, we are extending this side and this is called the exterior angle, and we are extending this and we are calling this as the exterior angle. If we call this is ABC, so without proof, you just remember A plus B plus C is going to become 360 degrees. Let's take a quadrilateral now. Now quadrilateral, extend one side, this is the exterior angle. Extend one side, this is the exterior angle. Extend one side, exterior angle. Extend one side, this is exterior angle. So you can call A, B, C, D. Then for this also, A plus B plus C plus D is going to become 360 degrees. As you can see, compare the triangle exterior angles and the quadrilateral exterior angles. The amount of the exterior, the size of the exterior angles are going to decrease slowly, so that the sum is becoming 360 degrees. They adjust themselves so that the sum of the exterior angles is going to be 360 degrees. Not only for triangle, quadrilateral, you take pentagon, hexagon, whatever it is, sum of exterior angles is always 360 degrees. Okay. And next, fourth property. Fourth property is about sum of interior angles. Sum of interior angles in any polygon. Now this is not a constant. It changes according to the number of sides. That is n minus 2 into 180 degrees. So where n is the number of sides. And what is n? N means the number of sides. Okay, let's take a triangle. Okay. First triangle we can prove easily. That is, let us say this is A and this is B and this is C. So I want to get the sum of all the angles of a triangle. What I do is I can do one construction. Draw a line which is parallel to the base. Okay. In the previous class we discussed, whenever two lines are parallel and there is a transversal, alternate interior angles are equal. So this is alternate interior with this angle. So if this is A, this will become A automatically, because we learned the property in last class. Whenever the lines are parallel and alternate interior angles are going to be equal. Similarly, this angle is going to be equal to this angle, because now these two are parallel and this is the transversal, so alternate interior angles are equal, so this is going to be C. Now you can clearly see ABC, they formed on the same straight line. So on the same straight line we are going to get a straight angle. So we got A plus B plus C is equal to 180 degrees. So this is the first proof we got. In any triangle, sum of interior angles is 180 degrees. So we can also understand by the help of formula also. In this formula you just substitute n is equal to 3, because number of sides of a triangle is 3. So 3 minus 2 into 180 degrees. So 3 minus 2 is 1, and 1 into 180 we got again 180. So is it matching? Yes. So not only for triangle, we can also use this formula for quadrilateral also. Okay, let us try for quadrilateral. So this is a quadrilateral. I want the sum of interior angles. 1, 2, 3, 4. So in place of n, we are going to use 4. So that is 4 minus 2 into 180 degrees. 4 minus 2 is 2. 2 into 180 is 360 degrees. That means in any quadrilateral, sum of interior angles is going to be 360 degrees. Let's take pentagon and then I'll open for doubts. So pentagon. How many sides are there for pentagon? There are 5. So use 5 in place of n. 5 minus 2 into 180 degrees. So now 5 minus 2 is 3. 3 into 180, that is 540 degrees. So in any pentagon, sum of interior angles 1, 2, 3, 4, 5. The sum of all the angles is going to be 540 degrees. Now students, any doubts still here? You can raise a hand. Amshuman, what is your doubt? Amshuman? Amshuman, are you there? Amshuman, you are not audible. Leave the class and join again. Abhiday, what is your doubt?
Sir, I didn't understand pentagon.
Pentagon, you want sum of interior angles? Okay, how many sides are there for pentagon?
Sir, 5.
So in place of n, we are going to use 5. So that is 5 minus 2 into 180 degrees. What is 5 minus 2?
Sir, 3.
3 into 180 is going to be 540, right? You understood? That is only substitution and simplification. That's it.
Okay, sir.
Okay. Akshara,
Sir,
yes, what's your doubt?
sir, for circle there is 0 sides. When you apply 0 minus 2, you get minus 360, but the angle is 360.
First of all, circle and side concept, we cannot put them together because circle is not formed by sides, it is a curve. Okay, these formulas are applicable only for polygon. Circle is not a polygon. Okay.
Okay, sir.
And Rishika, what is your doubt?
Sir,
Yes, Rishika.
I didn't understand triangle in interior angles.
Triangle interior angles. Okay. See, there are three angles for a triangle. We call them ABC. Okay. In last class, we discussed about the transversal properties. Do you remember all the pairs? Corresponding
Sir,
angles, alternate interior angles, alternate exterior, co-interior, co-exterior. Do you remember them?
yes, sir.
If the lines are parallel, we know alternate interior angles are equal, right?
Yes, sir.
As you can see here, that is this A and this A. They are alternate interior angles, right?
Yes, sir.
So they're going to be equal. That's why if this is A, this is also going to be A. And next, this angle and this angle also alternate interior.
Yes, sir.
So if the base angle is C, this angle is going to be C. Now you can see A, B, C. All the three angles are formed on the same straight line here, right?
Yes, sir.
Sum of them is going to become a straight angle.
Yes, sir.
Okay, that means sum is going to be 180 degrees. So this is how I proved sum of the angles in a triangle is 180 degrees. So similarly, we can get the other polygons by this formula, n minus 2 into 180 degrees. Okay.
Okay, sir.
Proofs are not important in your level. The proofs in geometry you'll be learning in 8th level, but now you can just remember the properties. Okay.
Okay, sir.
And Sanvi, what is your doubt? Sanvi.
Sir,
Yes, Sanvi.
so sum of exterior angles in quadrilaterals, not understood.
See, you take any polygon, whether it is triangle, quadrilateral, pentagon, anything. Okay. As you're
Okay.
increasing the number of sides also, the sum of exterior angles won't change. It will be exactly 360 degrees only because as the polygon size or the number of sides are increasing, the exterior angle sizes are decreasing, right?
Yes, sir.
They will adjust in such a way that sum is going to be 360 only. For any polygon, sum of exterior angles is going to be 360 degrees only. Is it clear?
Yes, sir.
Okay. Harshvardhan?
Sir,
Yes.
sir, why sum of exterior angles in polygon is 360? Why we are using sum of interior angles is one formula, sir, n minus 2 into 180. There is
There
no
are proofs. There are proofs, but they are out of your scope of your class. But if you want, I can explain. Okay.
sir, I
So
am
let's
saying
check how many of you can understand the sum of exterior angles proof because everybody is asking. So let's try to prove sum of exterior angles why it is 360 degrees. Okay. So what I do is first let me take something like so triangle and quadrilateral we already discussed, right? So let's take a pentagon. Let's take a pentagon and I'm producing all the sides so that I get exterior angles. Okay, so this exterior angle, exterior, 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 exterior. So let us call them A, B, C, D, E. I want to find the sum of all the exterior angles. What I do is you take a point at some other place and let's take, I have a ray here. Starting from that point, I'm drawing a line which is parallel to this ray. So I'm drawing a line which is parallel to this. That means this ray and this ray are parallel. And next, from the same point, I'm drawing a ray which is parallel to this ray now. Okay, so I can draw like this. Now, the angle between these two rays is A. So the angle between these two rays also going to be A because this is parallel to this and this is parallel to this. So why is it true? Because if you extend the sides and check with the transversal, they become corresponding angles. Okay. And similarly, now I'm drawing a ray which is parallel to this one. Okay. I'm going to get something like this. So if this is B, this is also going to be D. Okay. So that one let us write here. This is B and now I'm drawing a ray which is parallel to this, okay, like this. So if this is C, this is also going to be C. Now I'm drawing a ray which is parallel to this now, okay. So it is something like this. So if this is D, this is also going to be D. So let me write here D. And similarly, this is going to be equal to this. Let us write E here. Now you check from this figure. We know A plus B plus C plus D plus E is going to be 360 degrees. Why? Because the sum of all of them is going to become a complete angle. Complete angle measure is 360 degrees. That's why not only in pentagon, you take any polygon and do like this, you'll be getting all of them are adjusting to complete the sum is 360 degrees. That's why for any polygon, sum of exterior angles is 360 degrees. Harshavardhan, I hope your doubt is clear. I want you to raise a hand once, Harshavardhan. Harshavardhan, can you raise a hand? Is your doubt got clarified?
Yes, sir. Sir,
Okay.
I said that why
Yes.
you are using, sir, why all polygons?
For every polygon, sum is going to be 360 only for exterior angles. Even if you take hexagon, the number of sides, what I'm going to take, we'll get one more ray like this, but sum of all the six angles also 360 degrees, right?
Yes, sir. Sir, but why some of interior angles is not same?
No problem. We can even discuss that proof if you understand. Okay, no problem. I'm going to discuss. Okay, everybody listen to the proof of interior angles sum also, the proof. Okay, let's take a pentagon only. Not only pentagon, you can take anything. Okay. Um, Not pentagon. Let us take a number of vertices, any number of vertices, because the number of vertices we don't know. Let us say this is number of the vertex name is 1, and let us say this is 2, let us say this is 3, this is 4, and so on. I have n vertices. N means a variable, it can be anything. So if n is 10, there are 10 points. If n is 9, there are n points. So you have to imagine based on the number n. So before n, I have n minus 1 vertex. Before that, n minus 2. So many vertices are there depending on the value of n. Okay. Now what I do is, I'm going to join all of them. So 1 and 2, 3, 4. So I'm going to get a polygon. So here also all the sides are there. But because I don't know the number of vertices, I'm not joining. So what I do is, the interior angle at 1, I just write 1i. It shows the interior angle at 1. Now I'm producing this side and I'm calling this as 1e because exterior angle formed at 1. Similarly, this is going to be 2i. Let's extend this side and it's going to be 2e. Exterior angle formed at 2. And at vertex number 3, it is 3i. And you produce this, it's going to be 3e. Similarly, at every vertex, I have interior angle and I have exterior angle. NE means exterior angle. Okay. Now what I do is, first let me write 1e plus 2e plus 3e and so on up to ne. Okay. What is this? This is sum of exterior angles. We know sum of exterior angles of any polygon is 360 degrees. Let me write 360 degrees here. Then what I do is 1i plus 2i plus 3i and so on up to ni. This is going to be, we don't know this because we are finding the sum of interior angles only. Let us call it S. Okay, I'm just using a name S, sum of interior angles. Okay. Now what I do is I'm adding these two equations. If you add these two equations, 1i plus 1e. So what is from the figure? What is 1i plus 1e? Anyone will answer this? What is 1i plus 1e? I want that answer. Vishnu, can you answer this 1i plus 1e?
Sir, I actually,
Speak loudly, Vishnu.
sir, it is
From
180.
the figure, what is 1i plus 1e value?
Sir, 180.
Yes, why? Because they are formed on the same straight line, right?
Yes, sir.
Yes, very good, Vishnu. You got the correct answer. This is 180 degrees. And similarly, 2i plus 2e is going to be 180 because they are also linear pair. 180. And this 180 is going to repeat how many times? It's going to repeat n times. N times it is going to repeat. So the sum, what I can write, s plus 360 here. Now, 180 added n times, so it's going to become n into 180 degrees is equal to s plus 360 degrees. Now from this we can find the value of s. Transpose 360 degrees to the left side, so we'll be getting n into 180 degrees minus 360 degrees. Now what can be taken common? 180 can be taken common, so we'll be getting n minus 2 into 180 degrees. So finally we got the formula for sum of interior angles. What is this? N minus 2 into 180 degrees. So this is the formula. Okay. Harshvardhan, can you raise the hand again? Harshvardhan. Harshvardhan, you understood why we got the formula n minus 2 into 180 degrees?
Sir, why you written there n minus 2, sir?
Because I took 180 degrees common, no? So if you take 180 degrees common from 360, the factor 2 will remain. 180 into 2 is 360.
Yes, sir.
That's
Sir,
why. Okay.
factor there in n.
Yes. Now you understood the reason why we are using this formula.
Yes, sir.
So sum of exterior angles of any polygon is 360 degrees, and sum of interior angles of any polygon is equal to n minus 2 into 180 degrees. What is this n? It is a number of sides. And next topic we are going to discuss is about regular polygons. So before discussing a regular polygon, we need to understand two more terms. So what is equilateral polygon and other is equiangular polygon. Equiangular polygon. So what is equilateral polygon? So laterals means sides. Equilateral means if all the sides of a polygon are equal, then we call them equilateral polygon. So for example, I take a triangle. So in this triangle, all the sides measure are equal. This is equal to this is equal to this. We can call it an equilateral polygon. And I have a rhombus. In rhombus, we know all the sides are going to be equal. This, everything is equal. So it is the equilateral polygon. And you take a square. In square also, all the sides are equal. 1, 2, 3, 4. So this is equilateral polygon. And you take a pentagon. It is a regular pentagon. All the sides are equal. So this is also an equilateral pentagon, etc. So this list goes on. We have equilateral hexagon and so on. And the equiangular polygon, a polygon in which all the angles are equal. We call it equiangular polygon. Let us say this angle, this angle, this angle. If all the three angles are equal in a triangle, we call it equiangular triangle. Similarly, you take a rectangle. In rectangle, we know every angle is right angle, right, 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 right. All the angles are equal, so it is a equiangular polygon. Then we have a square. In square also, we have all the angles are 90 degrees, so equiangular. You can take a regular pentagon like this, then also all the angles are equal. So this list goes on. Okay, we have equiangular hexagon, equiangular septagon, everything. Okay, but when do you call it as an regular polygon? It should be both equilateral polygon and equiangular polygon. Then it is called regular polygon. So what is regular polygon definition? A polygon which is both equilateral and equiangular, then it is called a regular polygon. Okay. For example, let's take an equilateral triangle. Okay. Before taking the examples, first let us identify something about this rhombus. You concentrate on this rhombus. This rhombus is equilateral, but it may not be equiangular. Why? Because this angle is equal to this angle. Opposite angles are equal. This angle is equal to this angle, but all the angles may not be equal. That means a rhombus is equilateral, but may not be equiangular. You take this rectangle. If this rectangle is equiangular because all the angles are equal, but it may not be equilateral because only opposite sides are equal, but all the sides may not be equal. That means rectangle is equiangular but may not be equilateral. But you take the example of this square. Take this square. So you take a square. Square is always equilateral and equiangular. That's why we can call square as a regular polygon. So what is regular polygon? It is both equilateral and equiangular. Then we can call it as a regular polygon. So what are the examples for regular polygon we can take? Examples for regular polygon. Examples for regular polygon we can take. equilateral triangle we can say, or equiangular triangle we can say. This triangle, all the sides are equal and all the angles are equal. Okay, if all the angles are equal in a triangle, what is each interior angle? Amshuman, can you say what is each interior angle of a regular polygon having three sides? Amshuman, Amshuman, what is each interior angle here?
Hello, sir.
Amshuman, what is each interior angle in this triangle?
Sir.
What is this angle, and this angle?
Sir, 60 degrees.
Yeah, why 60 degrees?
Sir, because it is equilateral triangle, all having 60 degrees, sir. Sir, and somewhere 180, sir.
Yeah, some 180 and all are equal. So 180 divided by 3 is going to be 60. Correct answer. So in a triangle, if all the three angles are equal, we call it is equiangular triangle, and each angle is going to be 60 degrees. So you can take equilateral triangle as an example of regular polygon because it is equilateral and equiangular. Now you can take an example of square. So in square, all the sides are equal, we know that, and sum of all the interior angles is 360 degrees and divided by 4. 360 by 4, you're going to get exactly 90 degrees, all of them. And you take an example of regular pentagon. Okay, regular pentagon means all sides are equal and all angles are equal. Who will tell me each interior angle of a regular pentagon? Shriyash, will you say the each interior angle of a regular pentagon?
Yes, sir.
What is that?
Sir?
What is each interior angle of a regular pentagon? If all angles are equal.
Sir, 5 minus 2 into 180 by 5, sir.
Very good. Why are you doing 5 minus 2 into 180?
Sir, because we get sum of the angles, sir. We divide by 5, we get each angle, sir.
Okay, can you simplify that and tell me?
Okay, sir. Sir, 108 degrees, sir.
Very good. So it is 108 degrees. So how you got the answer? Shreyash, you can mute now. So sum of interior angles of a polygon, we already got the formula, that is n minus 2 into 180 degrees. Okay, in place of n, he's using 5 because there are 5 angles. So it is 5 minus 2 into 180 degrees. Now we want each interior angle. Each interior angle is divided by 5. So it's going to be 3 into 180 divided by 5. So 5 3s are 15 and 5 6 are 30. 36 into 3 is going to be 108. So this is how we are going to find each interior angle of a regular polygon, whether it may be having 5 sides, 6 sides, etc. So like this, so regular polygon list will continue. We have equilateral triangle, square, regular pentagon, and regular hexagon. Everything is possible. Okay. Now the next two properties are about regular polygons only. Okay. So already we discussed 4 properties regarding polygon. Now the fifth property. Fifth property is about regular polygon. That is, each exterior angle of a regular polygon having how many sides? N sides. Having N sides. You know, there is a short form to call this, that is also called n-gon. Polygon having N sides, in short we call n-gon. So it is now I want the answer from students. What is each exterior angle of a regular polygon having N sides? Who will answer this? What is each exterior angle of a regular polygon having N sides? Yes, Akshara?
So 360.
Yes. Can you explain why? Can you explain why? Akshara, a lot of background noise. Okay, can you check once? Yeah, Vishnu, you two guys got the same answer, 360 by n.
Yes, sir.
Can you explain why?
Sir, because each side is equal. And each exterior angle is equal. That's why.
Okay, sum is 360 and each is equal. To get each angle, we have to divide by n. Very good. So based on this, I'll ask you one question. Based on this property, what is each exterior angle? Each exterior angle of a decagon. You know what is decagon, Vishnu?
A polygon with 10 sides.
Yes, with 10 sides. Now, can you answer this question? What is each exterior angle of a decagon?
There is a decagon. Is it a regular decagon or a normal decagon?
Yeah, I forgot to write there. We are discussing about regular ones only. This is a regular decagon.
Sir, decagon has 10 sides and
Yes.
the total angle is 360.
Yes.
So 360 by 10,
Yes.
which is 30.
Yes. That means each exterior angle of a regular decagon is 36 degrees. Okay. So very good, Vishnu. So like this, you can use any regular polygon and you can find each exterior angle using this formula, that is 360 by n. And the next one is each interior angle. Each interior angle of a regular polygon having n sides. So who will answer this? Shriyansh already used that formula in one of the previous questions. Now I want the exact formula, what to be used here. Arish, can you answer this? Arish? Arish, are you there? Harshvardhan, can you answer?
Yes, sir. Sir, n minus 2 into 180 by n.
Very good. Can you explain why?
Sir, because that formula is used for interior for regular polygon.
Yes.
You are asking one n side, so we should divide by n.
Yeah, the numerator is sum of all the angles and we are dividing by n. So we'll get each interior angle. Okay. So already Shriyansh found each interior angle of a regular pentagon. Okay. Now I'm asking you a different question. What is each interior angle? What is each interior angle of a regular octagon? Can you see the answer for this? What is each interior angle of a regular octagon? Octagon means, you know, the number of sides. Harshvardhan? Harshvardhan, octagon means having how many sides? Not audible. Sanvi, can you answer this question? Sanvi,
Sir,
what is each interior angle of a regular octagon? You know, octagon means how many sides?
sir, 8 sides.
Okay, now can you find the answer for this?
Yes, sir. Sir, 8 minus 2 into 180 by 8.
8 minus 2 into 180 divided by 8. Okay, simplify this.
Sir, 8 minus 2, 6.
Okay, 8 minus 2 is 6.
Sir, 2 4s, 2 3s.
Okay,
Sir, 4. Sir, 4 45 by 180.
yes, now 45 into 3.
So 45 into 3.
You can split the number 45 in your head and use distributive property.
So 135.
Yes, 135 degrees. This is the each interior angle of a regular octagon. Okay. So this is about the concepts of polygon and the properties. So very good students, all of you responded very well and answered all the questions. So these are the properties you need to remember. Okay. And one more important thing about polygon we should have been discussed in the beginning only, but I forgot. So that is about interior, boundary, and exterior. You take any example of polygon. Let's take a triangle. Okay. See the set of all the points. This one is called interior. Okay, this is called the interior. Every simple closed figure will divide the plane into three disjoint sets: interior, and the set of points outside all the set of points is called exterior, and the line segments are the boundary. This is the boundary. So every simple closed figure, not only polygon, even circle also divides like this: interior, boundary, and exterior. Okay, and moreover, interior and boundary together they are called region. If you collect interior and boundary together, they are called region. Suppose if it is circle, we say circular region. Suppose if it is triangle, we call triangular region. If it is quadrilateral, we call quadrilateral region. So region means what? It is containing two things: interior as well as boundary. Okay. So even angle also has the same thing. See, angle like this. Angle. So this point A is in its interior, this point B is in its exterior, and this point C is on the boundary of the angle. Okay, and always vertex lies on the boundary only. O, the vertex O of this angle lies on the boundary. So this is about the polygons. Okay, and you need to remember all the properties: number of diagonals, interior and exterior angle formulas. Now let's answer the question from the previous year, that is 2023 exam. So all of you check this question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. So there are two statements. One is assertion and another one is reason. What is assertion? Right angle triangle is not a regular polygon. Reason: all the sides and angles of a regular polygon are equal. In the light of the above statements, choose the correct answer from the given options. Okay. So you have to choose option A. If both A and R are true and R is the correct explanation of A, you have to choose B. If A and R are true and R is not the correct explanation of A, you have to choose C. If A is true and R is false, you have to choose B. If A is false and R is true. Okay, who is going to answer this question with reasons? Sharath, can you answer this question? Sharath? Sharath, where you raise a hand? Yes, Abhyuday. Abhyuday, can you read assertion?
Sir,
Can you read the assertion statement?
okay, sir. Right angled triangle is not a regular polygon.
Yes. Do you think it is true or false?
Sir, true.
Why true? Can you explain?
Sir, sir, the sides of the right angled triangles are not equal.
You're saying sides or angles?
Sir, no, sir.
Again,
Sir,
what is the reason you said?
sir, the sides of the right angled triangles are not equal.
How do you know sides of a right angle triangle are not equal?
Sir, there is hypotenuse, sir.
Yeah, we know the property hypotenuse is always the longest side in a right angle. Very good. But how can you compare the angles? In a right angle triangle, are the angles equal?
No, sir.
Why?
Sir, one angle is right angle triangle and other are acute angles, sir.
See, sum of the all angles in a triangle is 180 degrees, and one angle is 90. So the remaining two angles sum only 90, right?
Yes, sir.
So definitely it's not going to be equal.
Sir?
Definitely they are not going to be equal, right?
Sir, your voice is stucky. Sir,
Abhyuday, I am saying that angles are not equal, okay?
Yes, sir.
If the angles are not equal, can it be an equiangular polygon?
No.
No.
Yes, sir.
And if it is not equiangular, it is not regular also, right?
Yes, sir.
Yes, the answer what you gave is correct. Assertion became true. Okay, assertion became true. What is that? Right angle triangle is not a regular polygon. Now, who will discuss this reason? Daksh, can you read the reason statement?
Sir,
Reason statement.
sir,
Read the statement.
the reason
Yes.
all the sides of angles of regular polygons are equal.
Okay, what do you think? It is true or false?
Sir, true.
All the sides and angles of a regular polygon are equal. That is true because it is from the definition of regular polygon only. So we got assertion true and reason true. Now, which student is going to select the correct option? Okay. Sriyansh, can you choose the correct option regarding this?
Yes, sir.
Okay.
Sir, both A and R are true. R is correct explanation of A.
Yes. We are able to say the assertion true based on the reason only. Right angle triangle is not a regular polygon. We said it is true depending on R only. If there is no reason, we cannot decide assertion. That means we are depending on R. So we can say R and A and R are true, and R is a correct explanation of A. But in some
Yes.
questions, assertion is true and reason is true. But to prove assertion is true, we don't use the reason at all. That means reason is not the correct explanation of A. Then you have to choose B. But for this question, which option is correct, Sriyash?
Sir, option A.
Option A, very good. So no need to solve, write any steps. This is only theoretical question. So option A, very good. So this is about the polygons and the properties. We'll be discussing and dealing with more questions later. So this is what the proof we gave. And next, types of triangles. The classification of triangles, it is based on two things. Sriyansh, you can mute. So triangles we can classify based on two things. One is based on sides and another classification is based on angles. So based on sides, we have first equilateral triangle. So what is equilateral triangle? Equilateral triangle means a triangle in which all the three sides are equal. This is equal to this is equal to this. So what are the properties we can write in equilateral triangle? That is, every angle is going to be 60 degrees. We already proved it. If you call each angle is x, we know sum of interior angles of a triangle is 180. So x plus x plus x is going to be 180. 3x is 180 and we get x is equal to 60. That means each interior angle is going to be 60 degrees. That is equilateral triangle. And next we have isosceles triangle. What is isosceles triangle? So isosceles triangle, a triangle is called an isosceles triangle if two sides are equal. And in the definition of isosceles triangle, there is no mentioning of the third side. It may be equal, may not be equal, we don't know. If two sides are equal, we can call isosceles. The third side may be equal, may not be equal. So according to this definition, every equilateral triangle also become isosceles triangle. Okay, but every isosceles may not be equilateral. It depends on the third side. So what is equilateral triangle? All the three sides must be equal. But isosceles triangle, if two sides are equal, we can call isosceles. According to this condition, every equilateral triangle also become isosceles triangle. They are not different. But to make isosceles triangle as equilateral, you need to know about the third side information. And isosceles triangle, there is a property, that is the angles opposite to the equal sides are going to be equal. Let us give the name of this triangle A, B and C. That is side AC, which is opposite to side AC, that is angle B. So you take angle B. And side AB, which is opposite to AB, that is C. So if two sides are equal in a triangle, their opposite angles are equal. So we can write, whenever AB equal to AC is given to you, their opposite angles are going to be equal. So we can say angle B is going to be equal to angle C. Converse also true. Converse also true. What do you mean by converse? Reverse. If you know sides are equal, we can decide angles are equal. Converse means what? Now you know if angles are equal, you can decide sides are going to be equal. Okay. So both ways it is true. If sides are equal, their opposite angles are equal. If angles are equal, their opposite sides are equal. This is isosceles triangle. And let's discuss about scalene triangle. What is scalene triangle? A triangle in which all the three sides are different. That means no two sides are equal. You can take a triangle like this. No two sides are equal. Let us use different number of strikes so that it is representing all the three are different. That is scalene triangle. Okay. So this is about the types of triangles based on sides. Now, types of triangles based on angles. The first one is, first I will complete the explanation, then I will go for doubts. So acute angle triangle. What is acute angle triangle? We know about acute angles already. An angle which lies between 0 and 90 is called acute angle. If every angle of a triangle is acute, then it is called acute angle triangle. That means you can say, let us say this is A, this is B, this is C. All three angles A, B, C must be acute angles. Okay. Every angle should lie between 0 and 90 only. Then it is called acute angle triangle. And then right angle triangle. What is right angle triangle? That is a triangle in which one angle is right. Okay. That is, let us say A, B, and this is C. This is a right angle triangle. Now the maximum number of right angles possible in a triangle is one only. We cannot have more than one right angle. Why? Because if two angles are right only, there is no space for third angle, because 90 plus 90 is going to become 180. That is the sum of angles in a right angle triangle. So either no right angle is possible or one right angle is possible, but more than one right angle is not possible. And one important terminology, one term is useful here, that is the side which is opposite to the right angle, we call is hypotenuse. What is this side called? It is called the hypotenuse. It's called hypotenuse. Okay. And one important property we remembered in right angle triangle, that is, let us say this is side 1 and let us say this is side 2. Okay. We know that is Pythagoras theorem. Very, very useful. Pythagoras theorem. You know, there is a famous story behind this, that is Baudhayana theorem also. He's an Indian mathematician who found this statement first, but he didn't prove. But Pythagoras came with the proof. That's why famously it is known as Pythagoras theorem. Okay. So Pythagoras theorem is nothing but the square of the hypotenuse is the sum of the squares of other two sides. That means AB square plus BC square. Hypotenuse square is equal to side square plus side square. Using this statement, in a right angle triangle, any two sides are given. We can find the third side using this. Hypotenuse square is equal to side square plus side square. And one more important property about hypotenuse, that is, this is the hypotenuse is the longest side in a right angle triangle. So never more than or longer than hypotenuse you will get. The other two sides are always shorter than hypotenuse only. Okay. And the third type is obtuse triangle or obtuse angled triangle. Now one angle will be more than this, more than right angle. Okay. So one angle is obtuse. So what is the maximum number of obtuse angles possible in a right angle in a triangle? One only. More than one not possible. Why? Because if you take two angles are more than 90 degrees, some is more than 180 is never possible in a triangle. Some should be always 180 degrees. Okay. And we don't call this hypotenuse, but this is the longest side, we can say. It is the longest side in an obtuse angle triangle. Okay. So this is about the classification of triangles. And one more important type of triangle will be there. That is a mix of both. That is a mix of, let's use yellow color. It is a mix of isosceles as well as right. Okay, let me draw it here. So this triangle is both right as well as isosceles. It is having a right angle and two sides are equal also. Then this type of triangle is called right isosceles triangle. Right isosceles triangle, a triangle which is both right as well as isosceles. So we can find the other two angles also. These two angles are also going to be equal, 45 degrees, 45 degrees. Now we can check the sum. 90 plus 45 plus 45. Yes, it is 180 degrees. So this type of triangle is right isosceles triangle. Now, any doubts in this classification you can ask. I'm lowering all the hands. Only doubts. You can raise a hand now. Doubts in the classification of triangles you can raise. Harshvardhan.
Sir,
Yes.
sir, I have that doubt in polygon, but my connection was gone, sir.
Speak loudly, Harshvardhan.
Sir, I have the doubt in polygon, sir, but that time my
No problem. You can ask now. What is your doubt?
sir in polygon, when can show that figure, sir? Once can it go?
First, you frame the question. If it is possible, I'll draw here only. What is your question?
Said that when the electricity was gone, there is no, sir, nothing stopped, so I cannot see. But you said no, sir, one octagon formula. You can explain that.
Harshvardhan, do one thing. You can follow that topic again from the recorded lecture. If you don't understand, ask me later in class. Okay?
Okay, sir. Sir.
Amshuman, what's your doubt? Amshuman.
Sir?
Yes.
Sir, you told the diagonals of the polygon, sir. Sir, that polygons finding diagonals have one pattern or not?
Yes, pattern is there because pattern is there. That's why we're able to find the formula n into n minus 3 by 2. If there is no pattern, we can identify the formula also.
Sir, why, sir?
See, I told you already in the class to find the nth prime number. To find the prime number, is there any formula available for us?
Sir, no.
For example, to find the even number, we have the formula that is 2 into n is going to be even number because they follow a particular pattern. But prime numbers are not following any particular pattern. So that's why we are not able to identify any formula regarding identifying the nth prime number. Okay?
Okay, sir.
And Abhiday, what is your doubt?
Sir?
Yes.
Sir, this a square equals to ab square plus b square is also known as hypotenuse square equals to side square.
Yes, hypotenuse square is equal to side square plus side square. But I wrote using the names of the line segments. Okay.
Two are same.
Come again?
Said that two are same.
Both are same. Yes.
Okay.
Aryan, what is your doubt?
Sir.
Yes.
Sir, you said no equilateral isosceles scale and triangle.
Yes.
Sir, do they have a meaning or is it just a name?
It is just a name having the definition. Equilateral means all the three sides are equal. Isosceles means two sides are equal.
Okay, sir.
Ashwardhan?
Sir?
Yes.
Sir, you can explain again Pythagoras theorem.
Pythagoras theorem. Okay. Even I want to elaborate Pythagoras theorem by taking some more examples. Okay. Let me take some more examples to explain about Pythagoras theorem. Okay, Pythagoras theorem is possible only in a right angle triangle. And suppose if integers satisfy Pythagoras theorem, let us say this is 3, this is 4, this is 5. Side square plus side square is equal to hypotenuse square. Is this true or false? 9 plus 16 is equal to 25. Okay, so we got 25 is equal to 25. True. That means 3, 4, 5 can be the sides of a right angle triangle, and such type of group together, that is 3, 4, 5. This is called Pythagorean triplets. They are called Pythagorean triplets. And similarly, to satisfy Pythagorean triplet, you know any integers? Some groups we must remember, they are very important, but I want any examples from your side. Who will answer? Vishnu, can you say any other Pythagorean triplets?
Sir, I actually had a doubt.
Yes.
Sir, what if the sides of a A right angle triangle are 2 and 2 and the hypotenuse is what?
2, hypotenuse is 1.
Sir,
You said,
what is the hypotenuse?
yeah, whenever the sides are 2, 2 and you want to find the hypotenuse. So actually you took a right isosceles triangle. It is right and two sides are equal. You're taking this 2 and this 2, right?
Yes, sir.
Yeah. Vishnu, I told you one relation between the hypotenuse and side of a right isosceles triangle. Do you remember? Actually, this is from perimeter area chapter. But do you remember the statement?
No, sir.
Hypotenuse is a right isosceles triangle is always root 2 times of the other side. I repeated so many times. So this is going to be 2 root 2. Without doing anything, we write 2 root 2. But if you want the proof, you just call it x. Okay, you just call it x. Then apply Pythagoras theorem. That is, hypotenuse square is equal to side square plus side square. 4 plus 4 is 8. So we get x is equal to root 8. 8 you can prime factorize. 2, 4, 2, 2. So you can square root of 2 into 2 into 2. So this is coming in pairs. So you can write outside the root. So it is 2 root 2, right?
Yes, sir.
So 2, 2, 2 root 2. But we don't call it Pythagorean triplet because 2 root 2 is not an integer. Okay? We want all integers, then only it is a Pythagorean triplet. Like this 3, 4, 5, I want some Pythagorean triplets. All are integers. Who will say? Akshara, you know anyone? Group? Akshara,
Yes, sir.
can you say any Pythagorean triplet group?
Example I can say, sir.
Come again?
Sir, I can say example.
Tell me one example.
5, 12, 13.
Very good. So this is also an important Pythagorean triplet to remember. 5, 12, 13. So you check 5 square plus 12 square is 13 square or not. 5 square is 25. 12 square is 144. 25 plus 144 is 169, which is 13 square. You know any other Akshara?
I'm doing.
Okay. Amshuman, can you say any other group?
Sir?
Yes.
Sir, 9, 12, 15, sir.
We are just multiplying this Pythagorean triplet, all of them by 3. Like that, we can create infinitely many Pythagorean triplet. I want which is not depending on these two. You said 3 3s are 9, 4 3s are 12, 5 3s are 15. Yes, by multiplying
Sir?
all the numbers by any common number, you can still create. But I don't want to be depending on this.
Sir, okay, sir.
Do you know any other?
Sir?
Do you know any other group?
Sir, sir, I try, sir. Sir, I will try.
Okay, okay. Vishnu, you know any other group? Pythagorean triplets?
8, 6, and 10.
Yes?
Sir, 8, 6, and 10.
8, 6, and 10. You are multiplying this by 2 and creating. 3 2s are 6, 4 2s are 8, and 5 2s are 10. Yes, 6, 8, 10 also Pythagorean triplet because 6 square plus 8 square is equal to 10 square. But I don't want to be depending on these to create a new one.
Sir, I've actually done like that. Sir, I've
Okay, I
actually.
can try for anything else. Sriyash?
Sir, 21, 29, 20.
Yes, 20, 21, and 29 is a Pythagorean triplet. Okay. Sriyash, I told you the method to create Pythagorean triplets. Do you remember?
Sir, no, sir.
Okay, I'll repeat again. But this is the correct answer. 20 square is 400. 21 square is 441. If you add them, you get 841. Yes, 29 square is 841. So can you create any other else? Yes, Amshuman, any other triplets?
Sir?
Yes.
Sir, no, sir. Sir, you take that method to find Pythagoras triplets.
Yes. Do you remember that method?
Sir, no, sir. Sir, one.
Okay, I'll repeat again now. But I want 2 or 3 examples next. Abhiday, do you know any other Pythagorean triplets? Yes. Arush? Arush?
Sir, can we use 3, 6 and 3, 6, 15?
Yes, 3, 6.
15.
No, that is not a Pythagorean triplet. You can check. Because 3 square plus 6 square is not going to be equal to 15 square. Then where you know any example? Danveer?
Sir, sir,
Yes. Shriyash, any other example?
Sir, I have 3 examples, sir.
Tell me.
Sir, 6, 8, 10.
I told you already. 6, 8, 10 are then not a new group. It can be created from this 3, 4, 5 group only. Multiply all of them by 2. You get 6, 8, 10, right?
Sir, 7, 24, 25.
7?
24, 25.
Yes, this one I can accept because 7 square is 49, 24 square is 576, and sum is 625. Yes. But you don't remember the method, Shriyansh?
Sir, no, sir.
Okay, I'll repeat again. So all of you, there is a requirement of creating Pythagorean triplets in solving some questions. So you can remember that method. Starting from any integer that you want, you can create always a Pythagorean triplet. Okay. So that is, first take any integer. Take any integer. Okay. Then what you do is check it is even or odd. Okay. If it is even, you go left. If it is odd, you go right. Okay. If it is even, first you make it half. Okay. If it is odd, first you make it square. Then in the even part, if after halving it, then what you do is you square it. And then what you do is you just take an integer which is predecessor of it. And after squaring it, you just take an integer which is successor of it. Similarly, while going to the odd part, first if it is an odd number, first you square it, then halve it. Then after getting that answer, just take an integer which is less than that, or predecessor we can say, and take an integer just more than that, we can take successor. Okay, this method we have to follow. So I will take an example for even and odd, then you can take your own examples. First I want to take any number I want. Okay, I'm taking 6. So 6 is an even number, so I'm going to the left side. So first I'm taking 6, just half 6, it is 3. Then what you need to do, square it. So after squaring it, 3 square is going to become 9. What is the integer just before it? 8. What is the integer just after it? 10. So these 6, 8, 10 are going to create the Pythagorean triplet for you. So you can check 6 square is 36, 8 square is 64, 36 plus 64 is going to be 100, which is 10 square. Now I'm going to take one odd number example. Okay, let me take 7. Okay, 7 is an odd number, so square it first. Don't half, square it first. 7 square is 49. Then you have to half. Okay, 49 half, it's going to be 24.5. Okay, take an integer just less than that, it is 24. Take an integer just more than that, it's going to be 25. So Sriyash, just now he told you an example, 7, 24, 25. Yes, this is also a Pythagorean triplet. That means you can create any Pythagorean triplet starting from the required number. Whatever you can take, it can all, the 3 group can be started with that number. Okay, so I want any student to take one example and get the answer, a Pythagorean triplet. Who will take a number? Any number that you want, whether it is even or odd. Sanvi, any integer you can take? Sanvi? Yes.
Sir,
Which number you want?
sir, 8.
Okay, 8 is even or odd?
Sir, even.
Even. So let's take 8. So even number, what is the first step?
Sir, we have to do half.
Okay, what is half of 8?
Sir, 4.
4. Okay, then we have to
Sir, square it.
square. 4 square?
Sir, 16.
16. Integer just less than that?
Sir, 15.
Integer just more than that.
Sir, 17.
17. So you can check 8, 15, 17. Are creating a Pythagorean triplet or not. 8 square is 64. 15 square is 225. 64 plus 225 is 289, which is 17 square. So you got a Pythagorean triplet?
Yes, sir.
Okay. Now let's take an example for odd number. So who will take an odd number? Any odd number you can take. Ritvik, can you take one odd number? Ritvik,
Sir,
can you take one odd number?
sir, yes, sir.
Tell me.
19.
Come again?
Sir, 19.
19, if you take, the numbers will be very large. Okay, no problem. Any number we can take. 19. 19, you square it.
361.
19 square, 361. And then we have to half it. 361 half. 361 you can split 360 and 1. 360 half, 180. 1 half, 0.5. Add them. Is it 180.5?
Yes, sir.
Okay. Now after having it, what we should do? Take an integer before that and after that. Which integer is before 180.5?
Sir, 180.
And which integer is just after that? 181. Okay. This is not a useful group because the numbers are very large and the question may not be created on this. But you can still check 19 square plus 180 square is going to become 181. Okay. So this is the method that we are going to create Pythagorean triplet that with a required undesired number. So this is about the classification of triangles, and let's solve the questions based on classification of triangles. Ritvik, you can mute. This question came in 2023 exam. Name the triangle shown below based on both sides as well as angles. So who is going to answer this? Yes, Daksh. Daksh, what is the answer? Correct answer?
Sir, option B.
You are saying scalene and right angle triangle. Can you explain why it is scalene?
Sir, because all sides are not equal.
Okay, no two sides are equal or all sides are unequal. It is scalene. And why is it right angle triangle?
Sir, because there is one right angle triangle. So
Yeah,
one.
the symbol for right angle triangle. So it is scalene as well as right angle triangle. So no process required. It is option B. Very good, Daksh. You can mute. So all the sides of the triangle are not equal and one angle is right. So it is scalene and right angle triangle. Simple question. Next, this question came in descriptive exam in 2017 for 5 marks. Okay. So name the types of following triangles. So there are 5 questions. So first one, triangle with lengths of sides 7 centimeter, 8 centimeter, and 9 centimeter. What do you name? How do you name the type? Who will answer this? Rishika. Question A. Which type? Rishika. Rishika, are you there? Dhanvir, can you answer question A? Which type it is?
Sir, scalene.
Very good. Can you explain why scalene?
Sir, it was same sides, sir. It was not
Same
there any
sides.
same sides.
No same sides. That means no two sides are equal. It is scalene. So who will option B? Who will answer option question B?
Sir, scalene.
Pranay, can you read B? Pranay, Pranay, can you read question B?
Sir, sir, sir,
Read
sir,
question
when,
B.
sir, no, sir, when you start the next subject, sir,
Come again?
sir, when you start the next subject,
I told you already, until completion of maths, we're going to deal with maths only because we have important topics left, geometry, mensuration.
okay, sir.
Okay. Can you read question B?
So B,
Yes.
A, B, C with A, B is equals to 8.7 centimeters AC is equal to 7 centimeters and BC is equal to 6 centimeters.
Okay, which type of triangle it is? You remember? You listen to the classification of triangles. Which type of triangle is this? Pranay, what happened?
Sir, I don't know, sir.
You're not following the class, Pranay. Listen to the recorded lecture again. Arush, can you answer? Arush,
Sir,
can you answer B?
sir, skeleton.
Yes, it is also scalene. The reason is
Sir, because AB is equals to 8.7
don't read
centimeters.
all that. Just say the final reason.
Sir, because the angles are not same and the centimeters are also not same.
Here there is nothing about angles. You can say no two sides are equal. Okay. And next, who is going to answer C? Okay. Abhiday.
Sir,
Yes.
sir, equilateral triangle.
Can you say the reason why?
Sir, all sides are, sir, 3 sides are equal.
Three sides are equivalent triangle. It is classified as equilateral triangle. And who will answer D? Who will answer D? Yes, Ritvik, can you answer D?
Sir,
Can you answer D? Which type it is?
sir, right angle triangle.
Can you say the reason why?
Sir, sir, angle D is equals to 90 degrees, sir.
Okay, that means one angle is 90 degrees. It is called right angle triangle. Very good. And who will answer E? Sanvi. Sanvi?
Sir,
Yes. Which type of triangle is E?
sir, the right angle.
Okay, but not perfect.
Right.
Okay, who will answer E? Sanvi, only half of your answer is correct. Vishnu,
Sir,
what is the answer? E.
sir, the answer is right isosceles triangle.
Can you say the reason why?
Sir, because X, Y, and Y, Z are equal and angle Y is equal to 90.
That means it is right because one angle is 90 degrees. It is isosceles because two sides are equal. So it is called right isosceles triangle, right?
Yes, sir.
Okay, Vishnu, you can mute. So these are the answers. Scalene, equilateral, right, and right isosceles. So these are about the types of triangles. And properties of triangle, we already discussed about the angle sum property. Let us revise once again. So let us say this is A, this is B, and this is C. Okay. So we already proved sum of interior angles is going to be 180 degrees. Let me revise once again. If you draw a line parallel to the base through the top vertex, so it's going to be looking like this. And you can extend even this side to understand whether it is a transversal or parallel. So you can see this line and this line are parallel and this is transversal. We discussed about alternate interior angles. If lines are parallel and that intersected by transversal, then alternate interior angles are going to be equal. If this is B, this is also going to be B. So we can write here angle B. Similarly, according to the same reason, now these two lines are parallel and this is transversal. This angle is equal to this angle because they are alternate interior angles. So we can write if this is C, this is also C. Now you can observe ABC are formed on the same straight line. So the sum of all the angles is going to be straight angle. That means sum of ABC is going to be 180 degrees. So I can write A plus B plus C is going to be 180 degrees. So we proved that sum of interior angles of a triangle is 180 degrees. So based on this, what is this property called? Angle sum property. Based on this angle sum property, so in the previous year papers you have many and many questions formed on this single property. Okay, angle sum property. Okay, so let's solve the questions based on angle sum property of a triangle. So what is angle sum property? In any triangle, sum of all the interior angles is going to be 180 degrees. So this question came in 2020 exam. In a triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the angles of the triangle. So who is going to answer this? Sure, then
Sir,
read the question again.
in the triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the angle of the find the angles of the triangle.
Okay.
Triangle.
Yes, how to solve this?
Sir, you can think the first angle is x.
Okay, first angle I called x.
Sir, so second angle becomes 2x.
Second angle become 2x.
Sir, and third angle becomes 3x.
Yes.
Sir, this is you said the 180.
Yeah, according to angle sum property, sum of any triangles angles is going to be 180 degrees. Okay.
Sir, add that 2x plus 3x plus x is equals to 6x.
Yes, 6x is equal to 180 degrees and we want to find the value of x.
Sir, x is equals to 180 divided by 60, it is equals to 30, sir.
Yes, 30. Now they're asking all the angles.
Sir, so x is equals to 30.
X is equal to 30.
Sir, 2x is equals to 60.
That is, in place of x, you have to substitute 30. 2 into 30 is 60.
Sir, 3x is equals to 90.
Yes, 3x is equal to 90. That is 3 into 30 is going to be 90. Okay. So 30, 60, 90. Which option?
Sir, option A.
That is option A. So then just a second, I'll share my screen again.
Okay, sir. Hello.
Yes, which option is correct, Ashwadhan?
Sir, option A.
That is option A. Yes, Ashwadhan, you can mute. So same textual solution also we have, that is the angles are 30, 60 and 90. And next question also came in 2020 exam. So you can see in the same year paper, we got 2 questions on this topic, angle sum property. So if angles A, B and C of a triangle are given 3x, 5x and 8x plus 4, then find all the 3 angles. Who is going to answer this? Same process. Raise a hand if you want to answer. Only few students. What about the remaining students just listening to the class but not answering? So it's almost the same process. Why can't you raise a hand and show your interest? Yes, Pranay, read the question again.
Sir,
Yes.
if angle A plus B plus T of a triangle ABC are 3x, 5x and 8x plus 4 respectively, then find all 3 angles.
Okay, what do you know about 3 angles of a triangle?
Sum of three angles is 180.
Can you write the equation? A plus
A
B
plus
plus C is equal to 180 degrees.
yes, sir.
Okay, next.
Sir, sir,
Next, what we need
3,
to do?
sir, 3x plus 5x plus 8x plus 4 is equals to 180.
Okay, according to the question, whatever expressions are given, we substituted. Now let us simplify this.
Sir, 16x is equals to 176.
Okay, you transposed for 176. Okay,
Sir, x is equals to 176 by 16.
okay. Can you
Sir,
divide
11.
everything? Yes, very
Sir,
good.
11.
16 ones and again 16 ones. X is 11. But we need to find all the three angles. What is A?
Sir, a is equals to 33.
3 into 11. In place of X, we need to substitute 11, 33 degrees. And what is B?
5 into 11 equals to 55 degrees.
55 degrees. And what is C?
Sir, sir, 11 8 into 11 plus 8 into 11 bracket plus 4 equals to 92.
Which option is correct, Pranay?
Sir, 33. Option is sir.
Yes, very good, Pranay. That's correct answer. You can mute now. So this is the answer. We got the x value is 11 and substituting back the value of x in all the expressions we got 33, 55 and 92. So this is the answer. And 2019 paper you got a question here, that is the angles of a triangle are in the ratio 1 is to 2 is to 3. Find the values of the angles. So direct question. You can even use one shortcut for this. Who's going to answer this? Sriyansh, read the question.
The angles of a triangle are in the ratio of 1 is to 2 is to 3. Find the values of the angles.
Okay, what is the shortest way possible for this?
Sir, 1 by 5 into 180.
Wrong.
Sir?
Wrong.
Sir, 1 by 6 into 180.
Yes.
Comma.
Yes.
2 by 6 into 180.
Yes.
3 by 6 into 180.
Okay. Which method you used here? We name one method for this. What is that? Indirectly, which formula you are using?
Yes, sir.
What is that formula name we are using in class?
Sir, share method.
Yeah, it is share formula. So every angle is receiving a share of 1 part out of 6 parts, 2 parts out of 6 parts, and 3 part out of 6 parts. So simplify this.
6 ones, 6 30s.
So what you can do is first do this and keep with you, and every time you need to multiply with the same number. Okay. What is
Okay.
180 by 6?
Sir?
What is 180 by 6?
Sir, 30.
Just 30 you multiply by 1, 2, 3. That's it. 1 into 30?
30.
30. 2 into 30?
60.
60. And 3 into 30?
90.
90. So the answer is A. But even if you just observe the options by going options method in elimination to save the time at the end, you can see only 30, 60, 90 are having the ratio 1 is to 2 is to 3, right?
Yes, sir.
If some other option also having the same ratio 1 is to 2 is to 3, then you need to check some of the angles is 180 or not. Okay?
Sir. Okay, sir.
Okay. So answer is A. So even you can do like this. You can call the first angle as x, second angle 2x, third angle 3x. Then also you get the answer. But this is the easy method. Directly you will get the final answer. So option A is correct. And next question, again you can see same 2019 paper, one more question based on angle sum property. So 3 into 2, 6 marks from the same concept. Which of the following measures of angles can be those of an isosceles triangle?
Sir, option C.
Sriyash, you want to answer this?
Yes, sir.
Okay. Which of the following measures of angles can be those of an isosceles triangle?
Sir, isosceles triangle means, sir, two angles are equal and one angle has been different, sir.
Okay. Then what is the answer?
Sir, option B, sir.
You said option B, right?
Yes,
Okay, if the two angles are 60 and 30, what is the third angle?
sir. 90.
60, 30, 90. Which type of triangle it is?
The scalene triangle.
But we want isosceles triangle.
Okay, sir. I will. Sir, option A, sir.
Yes, option A is correct. If the two angles are 90 and 45, what is the third angle?
Sir, 45.
So basically what you need to do is two angles are given in all the options. We have to find the third angle. I am doing that for first option, 180 minus 90 plus 45. Add the two and subtract from 180, you get the third angle. Now we can check 90, 45, 45. It is an isosceles triangle, right?
Yes, sir.
Option A. But Shreyansh, why are you giving wrong answers first, then giving correct answers?
I am confused, sir. It could be.
Do meditation.
Okay,
Okay.
sir.
So you're not focusing on the question, always in a hurry. First you give wrong answer, then you come up with the correct answer. Okay. Don't do that. Focus on the
Okay.
question. What are they asking? What I have to do? Why in a hurry? So nobody is giving time factor also. Okay. So don't be in a hurry. Focus the question, and uh, you are creating that on your own. Okay. So don't
Okay.
repeat that again. So the answer is option A. Okay, and we got the answer 90, 45, 45. So we created the uh, option, and it is answer A. And next question. So you can see in the textual solution also, for all the other options you can see the third angle. So they are not isosceles triangles. Next question came in 2018 exam based on the angle sum property. Which of the following measures of three angles can be those of a triangle? Simple question. Who is going to answer this? Daksh, read the question again. Daksh.
Sir,
Yes.
sir,
Read the question again.
which of the following measures the three angles can be those of a triangle?
What are they asking?
So which option measures the three angles of triangle?
That means where triangle is possible. Some options may not be possible to create a triangle, but which option is possible to create all the angles of a triangle? What do you know about three angles of a triangle, Daksh?
Sir,
What do you know about three angles of a triangle?
sir, sum of three angles is equals to 180 degrees.
So now which option?
Option A.
In option A, what is the sum you got?
Uh,
What is the sum?
sir, 200.
Is it in a triangle formed there?
Sum, sir.
No. What about the correct option then? See, you are first giving the answer and thinking. Don't do that. First think. I'm giving the time. First think and give the answer.
Option D.
Option D. What is the sum you got?
So 180.
180. So option D is correct. Simple. So just check the sum. That's it. So in all the other options, it is not 180, right? So
Yes,
option
sir.
D is correct. You can check all the sums in the textual solution. 200, 170, 360, and 180. Definitely option D is going to be the correct answer. Sorry, I wrote C, right? It is D. Next, 2016 descriptive exam for 2 marks. You got this question. One of the two equal angles of an isosceles triangle is 55. Then find all the measure of all the other angles. Okay. So you're going to answer this. Amshuman, read the question.
Sir,
Yes.
sir, can I read the question
Yeah.
again?
Yes, yes.
One of the two equal angles of an isosceles triangle measure 55. Then the measure of all the angles of the triangle.
Yes.
Sir, first we do 180 minus. Sir, 180 minus 110.
Why 110?
Sir, 55 into 2, sir.
Why 55 into 2?
Sir, there are two angles equal to 55 measures, sir.
They said one of the two equal angles is 55. So the second angle also become 55, right?
Yes, sir.
Now you want the third angle. So how can we solve this?
Sir, 55. Sir, 180 minus 55 into 2.
Yes. What is the answer?
Sir, 70.
180 minus 110 is 70. Now you write all the angles.
Sir, 70, comma 55, comma 55.
Yes, 70, 55, 55. Okay, this is the answer.
Yes, sir.
Okay, Amshuman, you can mute. So we got the answer 55, 55, 70. You can write in any order, no problem. So this is about angle sum property, and then we have properties of quadrilateral. Okay, this is very important topic, and time may not be sufficient for us. Okay, no problem. Let's try to discuss some of the properties of quadrilaterals. First property of the quadrilateral, that is number of diagonals. Number of diagonals of any quadrilateral is going to be 2. But how can we find 2? We got the formula for number of diagonals in a polygon already. That is n into n minus 3 by 2. So use 4 here. 4 into 4 minus 3 by 2. So 2 2s are 4 and 2 into 1 is 2. So the number of diagonals we got 2. For any quadrilateral is going to be 2. And then angle sum property. What is angle sum property? Similarly, how we discuss the angle sum property of triangle, for quadrilateral also, you take any type of quadrilateral. Let us say this is A, B, C, D. Angle A, B, C, and D. So we got sum of all the angles in any quadrilateral is going to be 360 degrees. Okay, so this is angle sum property. And then we have properties of all the different types of quadrilaterals. We'll discuss in the next class. But first, let us classify the quadrilaterals based on different conditions. So, quadrilaterals. First, we have a quadrilateral. Now, from this, we have trapezium. What is trapezium? A quadrilateral in which one pair of opposite sides are parallel. We call it trapezium. And if two opposite pairs are parallel, then it is called parallelogram. And in the parallelogram, if one angle become a right angle, it will become a rectangle. And in a parallelogram, if all the sides are equal, it's going to become a rhombus. And in a rectangle, if adjacent sides are equal, it's going to become square. And square can also be created from rhombus. In a rhombus, if all the angles are equal to 90 degrees, it become a square. And we have trapezium. One more type of trapezium is isosceles trapezium. Isosceles trapezium. And in quadrilateral, one more type is called kite. Kite is also called deltoid. Deltoid is in American English and kite is in British English. What is kite? Two pairs of adjacent sides are equal, it is called kite. And in kite, if all sides are equal, it's going to become rhombus. And one more type of quadrilateral also we discussed, that is arrowhead. So arrowhead is also a kite, but one angle is going to be more than 180 degrees, that is reflex angle. So this is the basic structure of we have types of quadrilateral. So this topic we are going to start tomorrow, and along with all the properties of all of them. What are the properties of trapezium, parallelogram, rectangle, rhombus, square, kite, arrowhead? And trapezium in American English is called trapezoid. So you have the notes with you already. So before we start tomorrow's class, classification of quadrilaters and properties, revise all of them and come. And tomorrow only we are going to start mensuration also. perimeter, area, surface area, volume, and then the final chapter will be left, that is data handling. So with that, mathematics division will be over. So keep revising the things. Okay, English, practice tests I uploaded up to class 8 also, so you can practice those tests to improve your English score also. And don't forget to revise your GK and intelligence topics also. Okay, so that's it, students. From today's class, we are going to continue from this topic in the next class, that is types of coordinates and their properties. Thank you for joining, students. You may leave the class now.